In this video, we're going to be looking at the quotient rule for exponents. Keep in mind that quotient has to do with division problems. So the quotient rule tells us that we're going to subtract our exponents of like bases. So look at the cloud bubble off to the right. We have a to the m power divided by a to the n power. And what the quotient rule says is we're going to keep that base of a, and then we're just going to subtract our powers, m minus n. So let's look at the first example. We have x to the 6th divided by x to the 4th. So the quotient rule says that we're going to subtract those powers. We're going to keep our like base of x, and then we're going to subtract our powers. Now, one thing to keep in mind is that you always want to start where the bigger power is. My bigger power is on top, and that's where I'm going to start. And that means that where I start is where I'm going to finish. So, of course, I'm going to finish with my end result being on the top for this problem. So 6 take away 4 is equal to 2. So we end up with x squared. Now number 6 says that we have y to the 3rd divided by y to the 8th. Now keep in mind on this problem we have more y's on the bottom. So that means I'm going to write my result on the bottom. I'm going to keep my base of y, but they're all going to go on the bottom. So 8 take away 3 is 5, but they're on the bottom. And so I need to keep those y's in the bottom, so I'm going to put in the understood 1 there in the numerator. Let's look at number 7. In 7, we have a little bit more going on. We have a coefficient, and then we have our y's. Well, our coefficients don't have the same base, so we can't subtract our powers. But what we can do is just divide this fraction by pulling out the greatest common factor. 4 and 16 both share a factor of 4, so I'm going to divide the numerator and the denominator by 4. So 4 divided by 4 is 1, and 16 divided by 4 is 4. So 4 over 16 simplifies to 1/4. Now let's move on to our y's. We have that like base. We have more y's on the bottom, so that means I'm going to keep my y's on the bottom when I finish. So 12 take away 10 is 2. So my answer is 1 over 4y squared. Number 8, we have 30 y to the 5th, z to the 3rd, divided by 5 y z to the 6th. So in this particular expression, we've got coefficients, we've got bases of y's, and we've got bases of z's. So let's just take each one separately. 30 over 5. Well, the nice thing is that 5 goes into 30 evenly. So I'm just going to do that division problem. 30 divided by 5 is 6, and it's a whole number, so it sits in the numerator. Now I'm going to move on to my y's. I have more y's on top, so I'm going to write my y, leftover y's on top. So I'm going to keep that base of y on top, and then I'm going to subtract. The y on the bottom has an understood exponent of 1. So 5 take away 1 is 4. So I have 6y to the 4th. All right, where do I have more z's? I have more z's on the bottom, so I need to write the result for the z's on the bottom. 6 take away 3 is 3. And again, they're going to go on the bottom. So it's very important that, that you start wherever the bigger number is. And the reason we're doing that is to avoid having negative exponents. It's easier now just to keep our exponents positive by just starting wherever the bigger number is. But an expression is not simplified if you have negative exponents in it.